Hello there, welcome to this video. In today's video we will discuss the artificial neural network and how it works. Before that, do you know? The concept of artificial neural networks has been around since the 1940s, but it wasn't until the development of computers and big data that they became practical to implement. ANNs are inspired by the structure and function of the human brain, but they do not work exactly like the brain. They are not as powerful as the brain in some tasks, but they are faster and more efficient in some other tasks. ANNs can be used in unsupervised learning, supervised learning, and reinforcement learning. Feel free to like and share this video in your network, and help others to learn and grow. So, have a look, what we will be taking away from this videos. Firstly, we will look into what is ANN or artificial neural network. Secondly, we will deep into how does the artificial neural network, ANN, work. Then step down with training of artificial neural network. Fourthly, advantages and disadvantages of ANN. Then applications of artificial neural network. And lastly we will sum up with conclusion. So without further ado, let me deep you to today's video. What is ANN or artificial neural network? An artificial neural network, ANN, is a type of machine learning algorithm modeled after the structure and function of the human brain. It consists of layers of interconnected neurons which process and transmit information. ANNs are used for a variety of tasks such as image recognition, natural language processing, and decision-making. They are particularly useful for tasks that involve large amounts of complex, unstructured data. How does the artificial neural network, ANN, work? An artificial neural network, ANN, works by processing and transmitting information through layers of interconnected neurons. Each neuron receives input from other neurons and processes that input using a set of weights. The output of each neuron is then passed on to the next layer of neurons. The input layer of the ANN receives the raw input data, which is then processed by one or more hidden layers. The output of the final hidden layer is passed on to the output layer, which produces the final output of the network. The neurons in an ANN are connected by connections called synapses. Each connection has a weight. The neurons adjust the weight to improve the performance of the model. The weights are typically initialized to small random values and are then adjusted during the training process. The process of adjusting the weights is known as backpropagation, which is an algorithm used to calculate the error between the network's output and the desired output. The error is then propagated back through the network, and the weights are adjusted to minimize the error. Once the model is trained, it can be used to make predictions on new data by passing the input through the network and getting the output from the output layer. Training of artificial neural network, ANN. Training an artificial neural network, ANN, involves adjusting the weights of the connections between neurons in the network so that it can accurately perform a specific task. The process of training an ANN is typically done using a set of labeled training data, where each example in the training data consists of an input and an associated desired output. There are a few key concepts that are important for understanding the training process of an ANN. Forward propagation. This is the process of passing the input through the network to produce an output. The input is passed through the layers of the network, and the output is produced by the output layer. Loss function. This is a measure of how well the network's output matches the desired output. The goal of training is to minimize the loss function. Common loss functions used in ANNs include mean squared error and cross entropy. Backpropagation. This is the process of adjusting the weights in the network to minimize the loss function. The error is calculated by comparing the network's output to the desired output. The error is then propagated back through the network, and the weights are adjusted in a way that reduces the error. Gradient descent. This is an optimization algorithm used to adjust the weights of the network. The algorithm calculates the gradient of the loss function with respect to the weights and updates the weights in the opposite direction of the gradient. This process is done until the loss function is minimized. Stochastic gradient descent, SGD. This is a variant of gradient descent. Instead of using the entire dataset to update the weights at each iteration, SGD uses a small subset of data called a batch or mini-batch to update the weights. Once the training is done, the network can be used to make predictions on new data by passing the input through the network and getting the output from the output layer. Advantages of artificial neural networks, ANNs. They are highly adaptable and can be used for a wide variety of tasks, such as image recognition, natural language processing, and decision-making. They can handle large amounts of complex, unstructured data. They can learn and improve over time with new data. They can be used to model nonlinear relationships and make predictions based on patterns in the data. They can be used in deep learning architectures, which consist of multiple layers of interconnected neurons, allowing for more advanced feature extraction and more accurate predictions. Disadvantages of artificial neural networks, ANNs. They can require a large amount of data to train effectively. They can be computationally expensive to train and run. They can be difficult to interpret and understand how they are making decisions. They can be prone to overfitting if not properly designed or regularized. They can be sensitive to the quality and pre-processing of the data, which may lead to poor results if the data is not prepared correctly. Applications of artificial neural network, ANN. Artificial neural networks, ANNs, have a wide range of applications across many different fields. Some of the most common applications include image recognition. ANNs are commonly used for tasks such as object detection, facial recognition, and image classification. Natural language processing. ANNs are used for tasks such as language translation, text classification, and sentiment analysis. Speech recognition. ANNs are used to recognize and transcribe spoken words and convert them into text. Predictive modeling. ANNs are used to predict future outcomes based on historical data, such as stock prices, weather forecasts, and demand forecasting. Robotics. ANNs are used in robotics for tasks such as navigation, manipulation, and perception. Healthcare. ANNs are used in healthcare for tasks such as image analysis, diagnosis, and treatment planning. Gaming. ANNs are used in gaming for tasks such as game strategy, opponent modeling, and adaptive game difficulty. Fraud detection. ANNs are used to detect fraudulent transactions in the financial industry. Recommender systems. ANNs are used to recommend items to users based on their preferences and past interactions with the system. Autonomous vehicles. ANNs are used in self-driving cars for tasks such as object detection, lane keeping, and traffic sign recognition. In conclusion, artificial neural networks, ANNs, are machine learning algorithms modeled after the structure and function of the human brain. They consist of layers of interconnected neurons which process and transmit information. ANNs are used for a variety of tasks such as image recognition, natural language processing, and decision-making. They are particularly useful for tasks that involve large amounts of complex, unstructured data. Training an ANN involves adjusting the weights of the connections between neurons in the network so that it can accurately perform a specific task. ANNs have many advantages such as highly adaptable, handle large amount of complex data, learn and improve over time with new data, and can be used in deep learning architectures. However, they also have some disadvantages such as require a large amount of data to train effectively, computationally expensive to train and run, difficult to interpret and understand, prone to overfitting and sensitive to the quality and pre-processing of the data. ANNs have wide range of applications across many different fields such as image recognition, natural language processing, speech recognition, predictive modeling, healthcare, gaming, fraud detection and autonomous vehicles. Hope you find this video valuable. Feel free to like, share and subscribe this channel. Your single like on this video keeps us motivated to bring more valuable content like this. Thank you for your support. See you in the next video. Till then, keep learning, keep growing.